Today we are going to be working on Unit 1, Lesson 4, Measuring Angles. So an angle is formed by two rays with the same endpoint. So an example would be if I have an endpoint right here, we'll call that endpoint A, and if I have angle or ray AC, and I have a second endpoint, and that second ray that shares the same endpoint, and it goes in this direction, we'll label that B. That forms an angle. And the way we write an angle when we are writing out our answers is that. So that's how we write angle. So right here, angle A. We want to name angle A in two other ways from this figure. So one, I could start at M, and I always want to go down to my angle and then back over. So I have angle MAC. Make sure you're always following the lines. You can't go anywhere else. So you can't say MCA because there is no line going in that direction. So MAC. We could also start at endpoint C and say CAM. So there's also angle CAM. Notice they both have A in the middle, which is good because that means they both share angle A. So that's why it's also called that in two different ways. There is a third way we can name it. There's a 1 inside here, so we could just say that it's angle 1. We want to look at angle classifications now. So looking at this angle is going to be called acute. And it's acute because it's an angle that's greater than 0. But it's also less than 90 degrees. This angle right here with this symbol, the little box, it means it's a right angle, which means the angle is 90 degrees. This angle right here, a straight line, or opposite rays, because they share an endpoint, they're going in opposite directions. This is a supplementary angle. And a supplementary angle is always 180 degrees. This angle here is called an obtuse angle. And it's an obtuse angle because it's greater than 90 degrees. So it's greater than 90, but it's also less than 180 degrees. Congruent angles are just two angles that have the same angle measure. So in example 2, we want to draw angles of the given description. These are going to be kind of estimates on my end. In class, we will do these using protractors. So if you are doing this because you are at home, you can do little estimates, and then when you come to class, I can show you how to use your protractor. So when I draw my angles, I usually start with my base ray. That's for horizontal. 50 degrees, well, I know 90 degrees would be straight up and down vertical. So 50 degrees is just a little bit more than halfway between 90 degrees. So it's going to be about in this direction. So this angle right here is 50 degrees. Next, I'm dealing with 120 degrees. So that means it's going to be larger than 90, but it's also going to be less than 180. So if I'm drawing this out, I'm going to start with my 1 ray, and I just make it horizontal. So I need it to be bigger than 90, so I need it on this side, but it can't be straight. And so 90 is an extra 30 degrees. So if this is 90 and I want to do an extra 30, it's just about in there. So this angle right here is 120 degrees. And remember, these are all estimates right now. I'm not using a protractor. See, I want 170 degrees. So it's definitely bigger than a right angle, and it's just smaller than a supplementary angle. So it's just 10 degrees less. So when I'm drawing this out, here's my base. So it's still opposite. I'm just going the opposite direction. That's perfectly fine. 90 degrees would be my vertical. 180 would be a straight line, but I'm 10 degrees short of that. So it's going to be just about right here. So this angle is 170 degrees. For example 3, we want to classify each of the labeled angles in the pentagon. So for all my angles, I have angle P. Well, technically I shouldn't say angle P, I should say angle TPQ. So TPQ, so I'm dealing with this angle right here. And that angle is acute because it's definitely less than 90, but it's bigger than 0 degrees. My next angle, if I want this angle right here, I could say is angle PQR. This angle still looks like it's just a little bit less than 90 degrees, so this is also acute. Next, if I'm looking at this angle right here, I could say that's angle QRS, angle QRS. And this is definitely larger than 90 degrees because a vertical would be straight up this way, so it's a little bit past. So since that's a little bit bigger, that would mean it's obtuse. I'm going to be looking down here at this angle. I have angle RST, so angle RST. This angle is also acute, so it's less than that. And lastly, we have this angle up here. I'm going to actually look at it this way, just so we have an example. If you notice, it looks like it's a 90-degree angle, so that means that angle STP is a right angle. The angle addition postulate states that if I have the measure, so the M in front of an angle symbol means the measure of the angle, COD. So if I have the measure of angle COD, that means I'm dealing with this angle right here, so everything on the inside of that. And if I add it to the measure of angle DOE, so DOE is that little angle, so everything inside of here. If I add the pink angle and the green angle together, they are going to equal the measure of angle COE. So it's like I'm putting them together. So if I add the two together, it makes up that whole large angle right there. So using the angle postulate, what is the measure of angle EOF? So angle EOF is right here. This is what I'm trying to find. That's like, we'll call it my X, what I don't know. I do know, however, that the measure of angle DOE is 42 degrees. So angle DOE, so this angle right here is 42 degrees. And I also know that the measure of angle DOF, so that's the whole angle right in here. I know that whole angle is 78 degrees. So what I know and what I don't know is I don't know that angle EOF, but I can use my X as that. And I know if I add these two small angles together, which I have one small angle of 42 and one small angle I don't know, if I add those two together, they're supposed to equal the large angle, which is 78. So then here becomes just a one-step problem. So I'm going to subtract 42 to both sides. That means x is going to end up equaling 36 degrees. So the measure of angle EOF equals 36 degrees. And if you double check that, if you do 42 plus 36, you'll get 78. So the measure of angle DOE equals 34. So I'm going to redraw this since I already drew all over it. So if I have, here's my D, E, and F. So I know the measure of angle DOE is 34 degrees. And the measure of angle EOF right here is 2x plus 10. Then I also have the measure of angle DOF, so this right here, which is the whole angle, is 6x. So again, if I write this out, my two smaller angles, 34 degrees and 2x plus 10, when I add those two together, they should equal my large angle, which is 6x, the angle addition postulate. So to solve this, do I have any like terms? Which I do. 34 and 10 are like terms. So that means I have 44 plus 2x equals 6x. Now I have like terms, however they're on opposite sides of the equal sign. So that means I want to take and move one to the other side. And I'm going to do that by looking at my 2x, and I'm going to subtract it to both sides of my equal sign. So that means I'm left with 44 equals 4x. So then lastly, to get x by itself, we are going to divide both sides by 4. 44 divided by 4 means x equals 11. So I figured out what x is, but it also says what is the angle measure of angle EOF. So EOF was my 2x plus 10. So that means if I replace my x with an 11, because that's what I found, 2 times 11 plus 10 is 32. So that means my measure of angle EOF is 32 degrees. Lastly, let's look at angle pairs. Vertical angles would be when we have two lines which are intersecting, and vertical angles would be these right here. So this angle and these angles, these are vertical, and that means that they are congruent. They have the same angles. And that also, we have these two angles are also congruent. So you have two sets of congruent angles when you're dealing with vertical angles. Adjacent angles are angles that share a ray. So if I have this angle here, then I also have this angle here. These two angles are sharing this ray. So that's what makes them adjacent. Complementary are going to be angles that are 90 degrees. So they add to be 90 degrees. So for instance, if I have a 60-degree angle and I'm adding that with a 30-degree angle, 60 plus 30 means I now have a 90-degree angle. Complementary. I could also have them where they're connected, which they're adjacent angles. So let's say I have this here, and I have this angle is 20 degrees and this angle is 70 degrees. These adjacent angles, when added together, are 90 degrees. So they are complementary. Supplementary means that they will be 180 degrees. So for example, if I have an angle and it's 110 degrees and I add it with another angle that's 80 degrees, 110 plus 80, 70 degrees, not 80. it'd be 180 degrees. Or we could also have adjacent angles that form it. So if I have one adjacent angle, that's 130 degrees, but then I'm also having another angle that's 50 degrees. Added together, those are going to be 180. So those are supplementary angles. I need to now identify angle pairs using this figure. I want complementary angles. Complementary angles are angles that have the same angle measure. So if I look at angle AOB, so angle AOB, which is 90 degrees, is also complementary to, that angle is complementary because it is 90 degrees. I also have another angle that's 90 degrees, which is angle BOD. So both of those angles are complementary because they form 90 degrees. But I also can take angle BOC, and if I add it, so this angle right here, if I add it to angle COD, these two angles right here form that 90 degree angle. So when I add them together, that means they're complementary. So my supplementary angles, so angles that add together to be 180 degrees, complementary was added to be 90 degrees. I first have angle AOD. They form that straight line. So angle AOD is supplementary. I have another one, which would be angle EOC. So angle EOC. So that's also a supplementary line because it forms that straight angle. But I also have a couple different ways. If I take angle AOB and I add it to angle BOC and COD, so these three angles right here, those three angles all form that straight line, which creates that 90 degree supplementary angle. So angle AOB plus angle BOC plus angle COD. There is another one, but we're just gonna leave that for right now. If you'd like me to show you later, come up to me and I will definitely let you know. Vertical angles, remember, are angles that are congruent to one another. So if I'm looking at a vertical angle, if I have angle COD, that would be congruent to angle AOE. So this angle here is congruent, these two. But I also have angle EOD. So this angle right here is congruent to angle AOC. Congruent angles are your vertical angles. So those are my two vertical angles. So congruent angles can be the vertical. So I'm going to just rewrite what I have up here, because since they are vertical, that means that they are congruent. So I have those two. But let's see if there's any other angles that may not be vertical but are also congruent. So I have those two, and then I'm also going to have angle AOB, which is my right angle, and angle BOD, which is my other right angle.